We're loaded up all these data centers, we're increasing data sets, but ultimately, no matter how much compute and data you throw at an artificial neural network, I think it would never fully replace what a human does.
Hello, and welcome to Environment Variables, brought to you by the Green Software Foundation. In each episode, we discuss the latest news and events surrounding green software. On our show, you can expect candid conversations with top experts in their field who have a passion for how to reduce the greenhouse gas emissions of software. I'm your host, Chris Adams.
Hello and welcome to Environment Variables podcast, where we give you the latest news and updates from the world of sustainable software development. So this week, I am your guest host, Anne Currie. You don't have the dulcet tones of Chris Adams. You're left with me this week. So we're going to do something a little bit different this week. I have got an old friend and colleague and co-author, Jamie Dobson, in to talk about it. So Jamie is the co-founder and CEO of a company called Container Solutions. And he's the author of the soon-to-be-released book, Visionaries, Rebels and Machines, which I've read, and that's what we'll be talking a lot about. He's also one of my co-authors of a book I wrote nearly 10 years ago called The Cloud Native Attitude, which is about the principles of moving into the cloud. And there's an awful lot in there about sustainability. And there's a lot we need to talk about around that. And it was actually, for me, the precursor to the book that I wrote, which came out with O'Reilly last year, with co-authors Sara, Sue, and Sara Bergman, Building Green Software, which, as I always say every week, everybody listening to this podcast should read because you'll find it very interesting and couldn't be more germane. So today we're going to talk about those three books really and the thematic links between them all, which are really about resource efficiency, building at scale without it costing a ridiculous amount of money or using a ridiculous amount of resources, and also resilience, which is something we're going to really have to focus on when it comes to running on renewable power. So let Jamie introduce himself and maybe tell us a little bit about his new book, Visionaries, Rebels, and I can never remember whether it's Rebels, Visionaries and Machines. It's Visionaries, Rebels and Machines. Go for it, Jamie.
Visionaries, Rebels and Machines. That's correct. Hello, Anne. Thanks for having me on the podcast, and hello to all your listeners who tune in every week. Yes, so my name is Jamie. I am indeed the co-founder of a company called Container Solutions, but I'm no longer, I should say, the chief exec, because I handed that role over about a year ago, which is probably why, or explains why I could find the time to finish writing this damn book. So Container Solutions is a company that specializes in cloud transformation, helping customers, get off whatever infrastructure they're running on now and get onto, efficient cloud infrastructure. And if we do that right, then it's kind of green and sustainable infrastructure, but it's hard to get right, which I'm sure we're going to discuss today.
Indeed, yes. So you've got a book that's about to come out, and which I have read, but it's not yet available in the stores, but it will be available in all good bookstores. Visionaries, Rebels, and Machines. And the reason why I asked you to come on is because I think there are a lot of ideas in there that we need to be talking about and thinking about. So tell us a little bit about Visionaries, Rebels, and Machines. And then I'll tell you why I think it's interesting.
Absolutely, yeah. So Visionaries, Rebels and Machines, we have to start at a point in time, and that point in time is about 4 or 5 years ago. And I was asked the question, what's the cloud? It was the person asking me was a junior colleague, new to Container Solutions. And, I started to answer, or at least I opened my mouth. And of course, I can answer that question, but I can't answer it necessarily succinctly. So I was asked the question, I think probably around about June, so maybe about 5 years ago today, actually. And over the summer period, I was thinking, God, how do you answer that question? What is the cloud? And so I started to creep backwards in time. Well, the cloud is, it's a bunch of computers in a warehouse somewhere. Well, what's a computer? And then once I asked that question, computers are things made up of transistors. Well, what's a transistor? And what I came to the conclusion over the summer was the following. The cloud can only really be understood in its own historical context. And so interestingly, once we got to the point of, answering the question, what is the cloud? The arrow was already flying. There was an arrow was shot round about the late Victorian time at Thomas Edison's Menlo Park facility in New Jersey. And that arrow flew all the way through the last century, through the web, through cloud computing, and it continues to fly with the rise of artificial intelligence. And so the last part of the book is, okay, now we know what the cloud is and what it does, where might it take us next in regards to the artificial neural networks and all of that stuff? So that was the book. The Visionaries and the Rebels are the people who built teams. They built teams that were innovative. All of them had psychological safety, even though that concept wasn't known at the time. And so these historical figures, and not just ancient history, like not just Thomas Edison, but also the Jeff Bezoses of the world, the Reed Hastings, and the modern figures of cloud computing, the Visionaries and the Rebels can teach the rest of us what to do with our machines, including how to make them sustainable.
And that is the interesting thing. So I enjoyed the book. It's a readable romp, and I very much connect with your initial motivation of trying to explain something that sounds simple, but actually you realize, oh gosh, I'm going to have to write an entire book to even get my own head around this, rather than, because that was true for when we wrote, is actually Cloud Native Attitude, which was the book that we wrote together, started off 10 years ago, was pretty much for the same, it was kicked off in the same way. We were saying, well, what is cloud native? What are people doing it for, and why are they doing it this way? And quite often, and building green software, the O'Reilly book, which is really germane to this podcast, was again the same thing. It's what does the future look like for systems to be sustainable? How do we align and make what is the future going to look like? And that's always seated in the past. What has been successful? How did we get here?
Absolutely. So you can't move into the future unless you understand your past. And I think the similarities between the Cloud Native Attitude and Visionaries and Rebels is the tone. So my book deals with horrible things, child poverty, exploitation of people. And the truth is that a reader will put up with that for maybe one paragraph. So if you want to teach computing and how it can enslave the human race or not, or how it can liberate them and touch all of these really difficult themes, you've got to do it in a pretty light-hearted manner. And the reason people are saying, oh, it's a page turner, it's entertaining, it's a bit of a romp, is because we focus on the characters and all the things that happens to them. And I think that started with a Cloud Native Attitude, because unless you can speak quite lightheartedly, you so quickly get bogged down in concepts that even for people like us who work in computing and are passionate about computing, it's just extremely boring. And there are some fantastic books out there right now about artificial intelligence, but they're so dry that their message fails to land. And I think I was trying to avoid that.
And for a while, because we wrote Cloud Native Attitude together, but it is kind of like, if these books are ideally a form of leadership. When you write a book, you're kind of saying, look, this is what I want to happen in the future. You're trying to lead people and explain and reason and inspire, but you have to inspire. If it's boring, you're not going to lead anyone. No one wants to follow you to the boring location. They want to follow you to the exciting location.
No, exactly. And I think the problem is computer people, most of us have been to university, so we're on the academic path. And what happens is you forget to tell stories. So everything becomes about what the research says, research indicates. So it's all exposition and no narrative. And the problem with that is people switch off very, very quickly. And the paradox is that you don't make your point because you've bored your reader to death.
Yeah. And this is something that comes up for me over and over again in the green software movement, that we quite often would tell a story of everything being very sad. And everybody goes, well, I don't want to be there in that sad world. But it's not a sad story. I mean, it's like climate change is a really sad story. It's terrible. It's something we need to avoid. We're running away from something, but we're also running towards something, because there's something amazing here, which is renewables are so cheap. If we can build systems that run on solar and wind and a little bit of storage, but much less storage than we currently expect, then we have a world in which there's really loads more power. We can do so much more than we do now. And it's just a matter of choosing what we do with it. We're not just running away from something, we're running towards something, which is amazing. And so, we tried to keep that tone. Building green software is designed to be fun. It's the only O'Reilly book. One of my reviewers said, it's the only O'Reilly book where you actually you laugh out loud whilst reading it. You could read it on the beach.
This is exactly why we created a conference at Container Solutions called WTF, what the F is cloud native. And it's basically because if you cannot entertain, you'll never get your message across. Now, I've got a question for you, Anne. This wonderful future that we're heading towards, I see it as well. But in the research for Visionaries and Rebels, there was a big chapter I had on Henry Ford, and in the end, it didn't quite make it into the book. But basically, once Edison had created electricity, then all of a sudden you had elevators for the first time. So the New York landscape did not become a thing till we had electricity, because there was a limit on how big the buildings could be. And that exact moment, Henry Ford came in with the motor car, and he was so successful in getting it off the production line cheaply, the beautiful boulevards of New York, of American cities, New York, St. Louis, and places like that, ended because basically people said, well, we don't need to be in the city, we can drive to the suburbs. And a lot of historians were saying, if Henry Ford had just gone a bit slower, we would have adapted to the motor car quicker, and therefore the cities of today would look very different. And one of my concerns with green software is the speed of which we're moving with data centers and AI is so quick. I wonder if we're having another motor car moment. So the future's within grasp, but if we go too quick, might we screw it up on the way?
So I think what you're circling around here is the idea of it's something that comes up quite often, which is Jevons paradox, which is the idea that as you get better at using something, you use more of it, becomes cheaper because there's untapped demand. So where people are going, do you know, I really, really want to live in a high-rise city, because then actually everybody can live together and it will be vastly better for us and we'll prefer it. And therefore we take more elevators and we go up because we've got elevators. And people really want cars. I mean, it's one of the things, I don't drive. But everybody loves to drive. There's no point in tying green with like nobody driving, because they love to drive. And there was untapped demand for it, and therefore it was met. And remember at the time, there was really, but back then we didn't consider there to be any problem with using more petrol. We didn't consider there to be any problem with using fossil fuels, and everybody went, yeah, hooray, let's use more and more of it. But it did massively improve our quality of life. So I think all green messages, we have to say, well, we want the improvement in quality of life, but we also want a planet. We have to optimize both of those in parallel. We can't say that you're trading off. And this, I know that people have a tendency to look down on efficiency improvements, but efficiency improvements are what has driven humanity up until now. And efficiency improvements are so much more powerful than we think. We just don't understand how much more efficient things can get.
Yeah.
And therefore we go, oh, well, you know, if people have 10 times as many cars or whatever, probably not 10 times as many, but well, compared to back to Henry Ford's days, we've got a lot more cars, we've got a lot more mobility. There is an almost seemingly limitless demand for cars. But there are plenty of other areas of life where efficiency has outstripped the demand. So in terms of electricity use, household electricity use in the West in the past 20, 30 years, household electricity use, despite the fact that everybody has automated their houses, everybody's got washing machines and dishwashers and tumble dryers and TVs and electricity use has still gone down. And the reason why it's gone down is because all of those devices appeared, but then became more and more and more efficient. And efficiency improvements really are extraordinarily powerful, much more than people realize. And if we force people to put the work in, and it's not free, it requires an enormous amount of work, but if people are motivated and incentivized to make those efficiency improvements, we can do an awful lot. We can get.
My suspicion is the world will change. So not many people realise that the car was actually very good for the environment. All around London, my children ask me, what's that thing outside the house? It's a scraper for your feet, for your boots. And that's because all the streets of London were caked 2-inch shit deep of horse manure. And at the end of every single street, it was piled high. So the public health issues with horses was an absolute nightmare. Not to mention the fact that people used to get kicked in the head or pulled into ditches. Fatalities from horses was a weekly occurrence in New York City. But so it changed. So once we got the electricity, we got the lifts, the horses went away. My suspicion is right now we cannot run a sustainable culture or city without radically changing things. So, for example, did you ever stop to wonder, why is your power pack warm? You know, when you charge your phone or your laptop, why does it get warm? Do you know what the answer to that question is?
No, I don't actually. That's a very good question.
Right. There you go. So who won the battle, Tesla or Edison?
Tesla didn't. Oh, maybe
Tesla
not.
did win.
Well,
So it's basically AC versus DC. What's the best system to have? Well, alternate DC, direct current, kills you. If you touch your direct current by accident and the voltage is right, you die. But what you feel on the back of your charger is heat, which is a side effect of converting AC back to DC, because computer devices don't work on AC because the current has to go round and round and round like water in a fountain, because that's the only way transistorized things work. So now people are saying, well, actually, arguably, we should have a DC grid, because globally we are wasting so much electricity because of this excess heat that is produced when we go from AC back to DC. So, and I get the feeling, and do you remember when we were kids, if you put your washing on at 3 a.m, you got cheaper electricity? I cannot help but think it's not just about renewable energy, but it's also the way we consume energy to make that more effective.
Yeah.
And I think if that doesn't change, I basically think when Edison arrived, society as we knew it absolutely changed. We had no refrigerators, and that changed our behaviors. Now, some people would say, well, you became a slave to the machine. I think that's a little bit too far, but we certainly went into some sort of analog digital relationship with the machines we work, all of which drive efficiencies. I think the next chapter for sustainable energy and computing will be a change in our habits, but I don't know exactly what they're going to be.
Oh, there's definitely a thing. It's something I've talked about on the podcast before. It's the mind shift from fossil fuels, which are kind of always on. It's easy to dispatch, so easy to turn on, easy to turn off, to to solar and wind, which is really expensive to store, really, really cheap if you use it as it is generated. But grids were designed, in many ways, this is the same kind of things that you talk about in your book. Grids were originally designed specifically to provide power that was easily dispatchable, and that it was fossil fuels. And that means that the whole of the philosophy of the grid is about something called supply side response. And that is basically saying, users, you don't need to worry. Flick of a switch, the electricity will always be there. And it's the responsibility of the providers of the electricity, of the grids, to make sure that the electricity is always there to meet your demand. You never have to think about it. But for renewables, it's generally agreed that what we're going to have to do is move to something called demand side response, where users are incentivized to change their use to match when the sun is shining and the wind is blowing. Right. As you say, when we were kids in the UK, we used to have something called Economy 7. You had 7 hours a day, which was usually at night, because it was all, because back in then, I'm guessing, because it was a coal-fired power station. Coal-fired power stations were not so easy to turn off and on again, which gas is, so we don't have it anymore. But in those days, say the coal-fired power station was running during the night and nobody was using the power. So we wanted to actually get people to try and use the power during the night. And we used effectively what are now called time of use tariffs to incentivize people to use spare power, which was during the night in the UK.
it sounds like a huge dislocation to life. But when I first came to London, the London mayor or the authorities made an announcement that went something like this: "Oh, air pollution's really bad today. Don't go out running. Close your windows. Old people, don't go out. Don't do any exercise." And I remember thinking, this can't be real. Is this some sort of prank? But this is a thing in London. And I remember thinking, but at no point would the mayor of London say, "Okay, the air pollution's bad. You're not allowed to drive your car today." And, right, and it shows where the priorities lie. But it wasn't that difficult. So everybody just shrugs their shoulders and says, "Oh, well, okay, I just won't do any outdoor activities today." So I think that demand side response is possible. I do wonder what happens though if, let's say, obviously the sun's shining, so that's the time you should run your data centers. What happens when the sun's not shining? Are the cloud providers going to be happy to have an asset sat there doing nothing when it's dark, for example, or when the wind's not blowing?
Well, it's interesting. I think it depends if it's all about what is the level of difference in electricity cost between the time when the sun is shining or the wind's blowing and the time when it isn't. I'm massively impressed by work that India is doing at the moment on this, on time of use tariffs, because they have tons of, and they know what they're looking forward. They already know they're one of the fastest growing. So India is one of the fastest growing countries in the world for rolling out solar power. Unsurprisingly, because it's pretty sunny in India. And so they're looking forward and they're thinking, well, hang on a minute, we're going to have this amazing amount of solar power in the future, but we're going to have to change people's behaviors to make sure that they run on it, not the other thing. So the way they're doing that is that the strategy that they're adopting for incentivizing people to change their behavior. And as you say, actually, people will change behavior. They just need a little bit of a push and some incentives, and they will change their behavior. The incentive they're using is time of use tariffs. And India is pushing out all of the provinces, the states in India to introduce time of use tariffs, which reflect the actual cost of electricity and push people towards times of the day when they're and it's a gradual process, but you can see that it will roll on and on and on. And they're looking at a tenfold difference. That what they're saying is that the difference should be tenfold between when your electricity is generated from the sun and when it isn't. And a tenfold difference in price does justify a lot of behavioral change. You might want to turn off your data center during the night, but some people will go, well, hang on a minute. If it's literally, because for most data centers, the main cost is electricity. If there's a tenfold difference in electricity cost between the day and the night, then they'll start to adapt and start to do less and start to turn things down. Necessity is the mother of invention. If you give a flat tariff to everybody, they're not going to make any changes. But if you start to actually incentivize response, demand side response, it will happen.
And then, of course, that comes back to regulation, doesn't it? Because I think one of the things that Edison, well, actually, it was his colleague Samuel Insull realised, it makes no sense to run the grid unless it's some sort of public utility or a natural monopoly. And you can only really fairly run a natural monopoly if the prices are negotiated and set in public and all the industry is regulated. So do you think that these tariffs, the time of use tariffs, will become part of the regulatory framework of the governments?
Oh, yeah. I mean, it already is. I say it's in India. It's a regulatory thing. It is part of the industrial strategy of India. Indirectly, the cloud providers will be regulated because they'll be regulated through the supply of electricity. Indeed, yeah. I mean, it's interesting. There's a battle in some European countries. It's happening at the moment. I think Spain already has time of use tariffs. There are other countries that have time of use tariffs, and it changes behaviour. And in the UK, there is a battle at the moment between suppliers about whether time of use tariffs are introduced. So that battle is kind of being spearheaded by the CEO of Octopus in the UK, Octopus Energy, Greg Jackson, isn't it? I think is really saying, look, this is what we need to do. Because, I mean, in the UK, it is ridiculous that the government really doesn't want they fear that everybody will be panicked and not be able to handle a time of use tariff, and it'll be, even though we used to have them not very long ago.
It's ridiculous. People always panic about the public sentiment, but you just need to look at COVID, how flexible people can be when they understand the need for it. That's number one. And number two, when I was a kid, and that's only 40 years ago, we used to turn the lights off because it was too expensive. So we did have different behaviour in the evening when we needed more electricity than in the daytime than when we didn't. It's not that difficult to imagine. You know what? Do you know what made me laugh? Is the average serving of meat, I think, in the 1970s was 200 grams. And if you look at 200 grams, it's actually quite tiny, sits on your plate like a little slither of lamb. And I was like, oh my God, that's not enough. That's not enough food. But then you realise that is what we all used to eat only 30 or 40 years ago. And so we've slowly been sort of, everything's been superstars, including what we expect from the electricity companies. I think a gradual shifting back, you'd barely notice it. And that's exactly how the government took salt out of our diet. They just slowly regulated how much salt could be in processed food until it had gone altogether.
Yeah. But I think you have to be careful about how you pitch this. But I think one of the issues with green is that it's pitched as, it's a reduction in meat and it's a reduction in this and a reduction in that. And I don't think it only has to be a sad story. It has to be a good story, something a hill that we want to take because it's worth taking, not just something that we're running away from. That I like the time of use tariff approach in India because it's saying, if you do this, you'll get electricity, which is a tenth of the price. It's a win. It's not just like run away from the bad thing, it's run towards the good thing. And it with a minor, and you're not saying change your behavior because we're ordering you to do it or because we're going to make electricity much more expensive, although inevitably fossil fuel electricity will become more expensive because it is naturally more expensive these days. Renewables have become so cheap.
Could cloud computing become a forcing function for cheaper electricity? Because the cloud providers need so much electricity, could this possibly accelerate the race to green energy?
Well, it definitely can, and it has done in the past. I mean, in the early days, so until maybe 5 years ago or so, the biggest non-governmental purchaser of renewable power in the world was Google, and they were buying renewable power. They were buying and bankrolling renewable power for their data centers, and they're not the biggest non-governmental purchaser of renewables anymore because it is now Amazon to power their data centers because they got a long way behind, and we all made a giant fuss about it and said, well, why aren't your data centers green? And so they put a whole load of money into renewables. A lot of the reason why there's enormous demand for renewables these days and enormous amounts of investment has gone into it was because of the cloud vendors. Now that is not because the cloud vendors are all secretly social justice warriors. I mean, they did it for their own benefit.
It's funny, but that's another pattern that reoccurs. Is so at the turn of the last century, so many entrepreneurs were sat on so much money that class unrest was really bubbling. So all of a sudden, you got the subway in New York, subway in Paris, the municipal control of transportation, all kinds of stuff. And then you left thinking, were they all do-gooders? Was that the reason they did that? Some of them may have been, but mainly they were trying to avoid class unrest. And so it's interesting that a good outcome can come on the back of self-interest. That is true, isn't it?
Yeah, it's true. And it's very hard to know what the unintended consequences, positive and negative, of all behaviours are. So a lot of investment in early stuff becomes wasted later. So you kind of like you mentioned subways, railways in the UK and worldwide, lots of early investment in railways resulted in loads of over-provisioning of railways. And then things got a bit more efficient and everybody goes, well, actually, you only need one train to go between London and Edinburgh, not 16 different trains on different lines. You get some kind of consolidation down and improvements in efficiency. And that's how actually things become cost effective, because actually over-provisioning is very cost ineffective.
Well, that's true, but that is a very cheeky way to transfer money from rich people to poor people, because obviously what happened is rich people invested in the railways. the railways were over provisioned. Those people never got a return. The rest of us were left with cheap railway infrastructure. Exactly the same happened with the internet. Everyone's like, right, we've got to wrap the world up in optic fibres. Private companies came in, private investors came in, paid for all of that. Then we had way too many optic fibre cables, and now we've all got practically free internet access. So occasionally it goes either way.
Yeah, and I have to say, I see the same thing with AI. So AI is interesting because on the one hand, I rail against how AI is unbelievably inefficient at the moment. There's an awful lot of talk about, we'll have to build nuclear because we need it for AI and all that kind of stuff. And we'll build all the nuclear and we'll build all the, and hopefully we need to kind of try and steer people towards doing it with nuclear and doing it with solar and wind rather than fossil fuels. But at the end, it's going to be, there's so much wasted, inefficient code in AI. AI is going to need a fraction of the power that we initially build to power the AI. I mean, because at the moment, I'm talking to people who are doing measurements and differences between different AI models that do, an equivalent amount of stuff. The ones that are optimized, 10,000 times more efficient, 600,000 times more efficient. I've even heard 1 million times more efficient. Yeah. There's so much waste in AI at the moment.
Absolutely. And I think people are not focused particularly on theoretical breakthroughs. So Geoffrey Hinton came up with the back propagation of errors in neural networks. I think it was about 1983. That's in the book, by the way. And that was a breakthrough. That breakthrough, that theoretical breakthrough, has got nothing to do with computing power or anything. It's a theoretical breakthrough. Right now, we're desperate for something like that. So we're loaded up all these data centers. We're increasing data sets. But ultimately, no matter how much compute and data you throw at an artificial neural network, I think it would never fully replace what a human does. So I think it's nice to know that as we lay down this computing infrastructure, and fingers crossed, all of it's powered by, renewable energy, in the background, researchers will be chipping away at the next theoretical breakthroughs. And I think they have to come with artificial intelligence, because I think there will be limits to what you can do with generative AI. And I think we're probably reaching them limits right now.
Well, improving AI efficiency does not require massive theoretical breakthroughs. It can be done using the same techniques that we've used for 30 years to improve the efficiency of software. It is just software. I mean, if you look at DeepSeek, for example, DeepSeek did have done, I think, so DeepSeek had to make their AI more efficient because the Biden administration said they can't have the fancy chips. So they just went, we can't have the fancy chips, so we're just going to make some software changes. And they did it like that, effectively. They're a tiny company, and they increased the efficiency tenfold pretty much instantly. They used 3 different methods, all of which, one of which is probably maxed out, and was probably most of the 10x. The others, there's still so much room for additional efficiency improvement with them. They got rid of over provisioning. They moved from 32-bit precision to 8-bit precision because they didn't need the 32-bit. That was a classic case of over-provisioning. So they've removed the over-provisioning, and that's been known about for years. That's not new. AI engineers have known that 32-bit is over-egging it, and they could run on 8-bit for years. So they didn't do anything new. They didn't have to do any new research. All they had to do was implement something that was well known, but people just couldn't be asked doing.
Yeah, all of this noise will soon die down, and people behind the scenes, away from the attention-grabbing headlines, will continue to crack on with these things. And so my prediction is that everybody's going to be pissed off in the next 6 to 12 months. AI failed to deliver, but in the background, use cases will get pieced together. People will find these optimizations, they'll make it cheaper. And I do reckon, ultimately, generative AI will sink into the background, just in the same way that nobody really talks about the internet, right? It's the web, or it's mobile phone applications that do something sat on top of the computer network infrastructure. I think that's probably what's going to happen.
I suspect that generative AI is not going to entirely disappear, just because. So I used to work many years ago. I worked in the fashion industry. I worked for a company that was one of the first pure play internet e-commerce companies, and because it was fashion, we used a lot of photography. an awful lot of photography and a lot of it. We had a whole team of editors. So, I can see companies that work with photography, they have it's a surprisingly large number of people in the world are edit photographs. And so, that there's a huge demand for making that easier. I mean, the downside is that you then, even now, all photographs you see online represent people who do not exist. It's like all models you see. It's probably not that model. It's kind of based on a person.
It's a mashup of lots of people, isn't it? Yeah. So I think that generative AI stuff will remain, but I think it will become specific. So, for example, I saw yesterday that the government are piecing together a number of different tools. That's let's call that the substrate. But on top of that, it's to give civil servants conversational interface about what was our policies. Can you summarize this for me? Can you suggest a new policy, which is dangerous because any decision based on past data is a reflection of what's happened and not necessarily a vision of what could be. So I think that's probably what's going to happen. But I could be wrong, and because the truth is, none of us actually know. It's all speculation at this point.
Yes. So before we're well, actually we've still got a bit of time. But before we go, I want to focus a little bit on what I see are the themes that run through the creation of the internet and the creation of modern technology in Visionaries, Rebels and Machines, and the cloud native attitude and building green software. And I think a lot of the themes there are trying to deliver your results, the thing that you want, the thing that's going to improve your life, or the thing that people think is going to improve their life on fewer resources, with fewer resources, because that's the only way it scales. The cloud was essentially all about how do we deliver our Google's. I mean, the cloud came out of Google. Then it came out of Google, which was the first hyperscaler. And Google was saying, well, actually, we really need to deliver our services at an incredible scale, but we can't spend there's a limit to how much money we can spend on doing it. So we have to do it using operational efficiency and code efficiency so that we deliver this service on fewer resources. And also resilience, because things fail at scale, and therefore we need to be resilient to failure. But that efficiency and that ability to respond to changing circumstances is exactly what we need to handle the energy transition.
So I think the common theme that goes all the way from Thomas Edison to the teams building systems using AI now is that technologies change, but human nature doesn't. So the way those teams were managed has been absolutely consistent. I think one of the great contributions of Visionaries and Rebels is to show to people, you don't need to change the way you manage your techies, because actually this is a series of success stories that lasted 150 years. The second theme is that once the foundations are laid, it is not the creators of a technology that dictate its destiny, but the users. So once we had a grid, boof, people started inventing applications. Exactly the same. Once the internet was there, people started inventing web applications. And once the cloud was there, we had Netflix, and then we had Starling Bank, and all the things built on top of the substrate. So I think for sure what's going to come next for sustainable computing will not necessarily be dictated by those building cloud infrastructure, but it's the teams out there, the safe teams, the innovative teams taking risks. I think they will find the use cases. They will dictate what happens next.
But so that's interesting, because that actually instantly reminds me of the approach that India, which we already talked about, that India are taking, where you say, well, look, we'll incentivize people to stick a whole load of renewable power into the local grid, into the grid. We've got the grid just distributes the power. And we introduce those incentivizing time of use tariffs. And we say, look, there's really cheap energy at these times. Fill your boots. You decide what you're going to do with it. And then just leaving the users of the grid, the users of those time of use tariffs, to work out what's going to happen.
Yeah, and I think people will look to India. I think everybody looks at other countries that are doing these experiments. So if it works out in India, then of course you could imagine that other countries might say, oh, well, that's actually worked out over there. We can copy that as well. But ultimately, they're building on existing infrastructures. They say, well, this is what we've got. what does that interface between our users look like? And by making a change there, they will change user behavior somewhere else. But it's hard to predict, though. It's hard to predict.
It is hard to predict. It's an interesting, something that comes up in grid discussions about this quite often is this whole kind of idea that in some ways, countries that are less developed than America and the UK are in a much better position for the energy transition, because governments can go, we'll have time of use tariffs and everybody will it's not that far for, people are quite used to microgrids. They're quite used to things being fluctuating. They haven't got used to everything being available at the flick of a switch and 100% reliable. Reliability, to a certain extent, breeds fragility. It breeds people who haven't forgotten how to handle
the change. Yeah. So, of course, there are places in the world that have got cell phone infrastructure, but they don't have any telecommunications infrastructure, because by the time they came around to installing it, cell phones were a thing. So they just completely skipped that whole step in technology. We've still got phone boxes in the UK that nobody knows what to do with. They're on the street corners growing moss. And that's a legacy, exactly like what I mentioned earlier, the mud scrapers outside of people's houses. These are a legacy of previous sort of infrastructure. Horses in the case of the scraper, and then the telephone boxes in the case of cell phones. So I think that's true, that India probably has got places that are either off-grid or nowhere near as reliable as what we have, for example, in the UK. So then it makes sense that the government can be more experimental, because the people are not going to lose anything. There's nothing to lose. There's only gains.
Indeed, yes. And in fact, actually, I mean, it is interesting that time of use tariffs being introduced in the UK is now controversial, because we have become strategic snowflakes. We can't, they fear that we can't change, although I think they're wrong. And in fact, time of use tariffs were totally fine 30 years ago. Nobody died as a result of Economy 7 heating.
There's an absolute relationship between the reliability of a system and how spoiled its users become. So when I first went to the Netherlands, the train would be 2 minutes late and people would literally slam their feet on the ground in anger, right? And swear in Dutch about the state of the NS. Coming from the UK, it's like, well, whatever. Now, exactly the same happened when the video store came along. Most people were used to consuming media as and when they chose to. But with the video shop, they only had limited editions of new releases. The frustration that created in users of video stores is exactly what led to Netflix's creation. So the more reliable something is, the more complacent and the higher the expectations its users have of the system. But I think COVID taught the UK government that we can be way more flexible than they fear we are.
Yeah, I agree. And actually, I don't think they learned that lesson, because they immediately forgot it again.
And apparently, there's loads of lessons they didn't learn, because apparently we're less ready for a pandemic now than we were before COVID.
Yeah, it's amazing how many lessons we didn't learn. But I think that takes us to a final thing that we should discuss, which I think comes out of what you've just said there about resilience. Which is something that is a modern thing that we talk about a little bit in the book, in all those 3 books, which is chaos engineering, which is the modern approach to resilience, which is that you get more resilient systems by building them on top of systems that you don't expect to be 100% resilient. The expectations of 100% availability, supply side response, builds, in the end, more fragile systems.
The fragility has to go somewhere. So the more resilient the system is, the more fragile the users are. And then the converse of that is true. The more system fails, the more flexible its users become, and the more workarounds they have, because they're not sure it's going to be ready. I do know one of the key lessons I took while I was putting Visionaries and Rebels together was could be distilled into one sentence: a system that doesn't fail during its development will fail catastrophically in production. And so what you're left with is the electricity grid, the internet, the cloud computing. They're so amazingly, resilient and reliable. They are literally always there. And you do start to take them for granted. But the paradox is that if you want to create resilient systems, you've got to stimulate failure in order to learn how to deal with failure, therefore avoid it in the future. It's all a little bit circular, really.
Yeah. Yeah. So the irony is that exposing end users to the fluctuation in the availability and price of electricity for renewables, it sounds scary, but it will produce in the end a more resilient society, a more resilient system on a countrywide scale.
And in your opinion, what's the relationship between these type of tariffs and demand side behavior and cloud computing? Where is the link there?
Well, I mean, data centers are users of a grid. They are prime users of electricity. If we make a tenfold difference, and I don't think it's going to work for anything less than a tenfold difference in price, we will start to see behavioral change. We will start to see data centers go, do you know, is there a way that we can reduce the number of machines that are running? Because at that point, the cost will start. So we need to get it to a point where the cost, the different time of use tariff costs, make it worthwhile switching to operations to when the sun is shining, the wind's away. But that is what we have to do, because we need the demand side response behavior. We need the change of response from users. So we have to make it work.
Essentially, you're going to use economic nudges to make data centers consume green energy. Right. So that's the energy side of the equation. What do we do about water supply? So I don't know if you realize, but lots of data centers have been refused planning permission because they would drain fresh water from people's houses. And even our governments can't quite, not ready to sort of take that on the chin. Yeah. So what is your thoughts on the water issue? Well,
again, that is a known issue. If we actually, at the moment, if they don't have to do it, they won't do it. So cooling using water is very cheap and easy. And therefore they do. That's what they do. That is the default. But there are alternatives. I mean, if you look at more modern chips that are, Intel, it's a bit of an old-fashioned chip these days. It's very hot. The NVIDIA chips are very hot, but there are chips that are coming out that are much more efficient, they're much cooler, that are often designed to be air-cooled, not water-cooled. So if we move towards, so it is not unknown, the technology exists for chips that don't get so hot that they require water cooling. The future is chips that can be air-cooled. And if they can be air-cooled, they're cooled with aircon. And aircon can be fueled by solar power, because obviously, it's when it's hot and it's sunny that you have the biggest problem with heating. If it's not sunny and warm, it's less of an issue. So the future here, the solution is better and more efficient chips, hardware that can be air cooled. That is for most hardware. I think that has to be that is at least a big part of the solution.
And does the future involve huge data centers that fall under government regulation? Because one of the reasons why the electricity grid became a natural monopoly is because it made no sense to put 6 sets of cables down. There wouldn't be enough space in the street. And actually, the electricity providers couldn't get economies of scale and therefore could not pass on cheap electricity to its users, and therefore electricity would never become widespread. So is there a similar argument for the cloud providers presently?
Well, I have to say, I'm a huge believer that we just do it through pricing, that we want data centers to be close to, so in Scotland, and we turn off when we pay wind farms to turn off. We spend billions and billions of pounds every year paying wind farms to turn off because there is no user for that power within easy reach of that wind farm. And we're only talking about Scotland. We're not talking about Siberia. So
I think we could build a data center there then.
Why don't we build a data center there?
Because they've got plenty of wind and water.
And an extremely well-educated workforce. And it's a bit cooler up there as well. So you don't need to do quite so much cooling anyway. But there's no incentive. So while there's no incentive, people won't act. Once there is incentive and a really juicy incentive in place, a 10x difference in price, we will see behavioral change. Because we do. Humans are very good at changing their behavior, but only if there's a good reason to do so.
Yeah, absolutely. Yeah.
And actually, that kind of brings us to the end of our hour. I think we've had a really interesting discussion. I hope the readers, the listeners, and potentially in the future readers have enjoyed the discussion. All the links for everything we talked about, all the books, all the comments, will be in the show notes below. So you can go and have a look. You have to, you can pre-order Jamie's book, Visionaries, Rebels and Machines on Amazon or any good bookshop now. You can also buy The Cloud Native Attitude or Building Green Software, which you can also read for free if you have an O'Reilly subscription. And when I get round to it, I'm eventually getting a Creative Commons Building Green Software, and kick me. Everybody should be kicking me all the time to do that because it's just a bit of work that I need to do. Anyway, so Jamie, thank you so much for being on the podcast. I've really enjoyed our chat. Is there anything final you want to say before we disappear off?
Nothing final from me. The book launch, there'll be a launch party in London at some point. It's available on Kindle, but for now, I'm just happy to get, feedback. And it's been great to talk to you today, Anne, and I really hope your listeners took something away from this.
So I hope people enjoyed the conversation. It was a little bit of an author's book club, a bit different to normal. But I hope you enjoyed it, and let us know if you want to hear more of this kind of discussion. Thank you very much, and until we meet again, goodbye from me.
Hey everyone, thanks for listening. Just a reminder to follow Environment Variables on Apple Podcasts, Spotify, or wherever you get your podcasts. And please do leave a rating and review if you like what we're doing. It helps other people discover the show, and of course, we'd love to have more listeners. To find out more about the Green Software Foundation, please visit greensoftware.foundation. That's greensoftware.foundation in any browser. Thanks again, and see you in the next episode.